So this question is from communication, and he said given the autocorrelation function for a stationary process is Rxx of tau is 25 plus 4 by 6 tau, find the variance of the process x of t. Variance is nothing but mean square value minus square of the mean square value minus square of the mean, right. So mean square value which is also called as the total power, mean square value can be obtained from autocorrelation function by observing the autocorrelation function at tau is equal to 0. Autocorrelation at tau is equal to 0 gives the mean square value. So which comes to be how much? 20, tau is equal to 0 if I substitute 29, and square of the mean can be obtained from the autocorrelation by substituting tau is equal to infinite. Basically, actually a condition must be satisfied. If the random process is ergodic, then only autocorrelation function at tau is equal to infinite gives the square of the mean, but here he didn't specify anything, right. Directly also we can take. So autocorrelation at tau is equal to infinite. If I substitute infinite, what happens? It is 25. So variance is equal to mean square value minus square of the mean. What is that we are going to get? 4. Option 1 becomes the answer. Option 1 is the answer. Hope you understood this question. Let us look at the next question. Yeah. The power spectrum or power spectral density, power spectrum Sxx of omega for the random process that the autocorrelation function is given, and is asking us to find out the power spectral density. See, in random process there is one famous relation called Wiener-Khinchin relation. Wiener-Khinchin relation, which states that autocorrelation function Rxx of tau and power spectral density Sxx of omega, they form a Fourier transform pair. Autocorrelation function and power spectral density, they form a Fourier transform pair. Means what? Fourier transform of autocorrelation gives power spectral density, or inverse Fourier transform of power spectral density gives autocorrelation function. Now in our case autocorrelation function is given and is asking us to find out the power spectral density. How to calculate? See, to the given autocorrelation function, simply calculate the continuous time Fourier transform. So Rxx of tau, the given autocorrelation function, can be written as a square by 2. See, cos omega naught tau. How can you write cos omega naught tau? E power j omega naught tau plus e power minus j omega naught tau divided by 2, right. Or this is nothing but a square by 4 into e power j omega naught tau plus e power minus j omega naught tau, isn't it? Now apply the Fourier transform. Sxx of omega, that is the power spectral density, is a square by 4. What is the Fourier transform of a complex exponential e power j omega naught tau? See, if you recollect your standard Fourier transform pairs, e power j omega naught t forms a continuous time Fourier transform pair with 2 pi into del of omega minus omega naught, right. So 2 pi into del of omega minus omega naught plus for this one 2 pi into del of omega plus omega naught. Cos Fourier transform is 2 impulses you will get now. So this is nothing but a square pi by 2 into del of omega minus omega naught plus del of omega plus omega naught. A square pi by 2 into del of omega minus omega naught plus del of omega plus omega naught. Yes, option 4 becomes the answer. Simple question. Option 4 becomes the answer, right? Let us look at the next question. Yeah, 49th question, and he said the power spectral density of white noise is, so, and in brackets he specified eta is a real positive constant. Okay, so the power spectral density of white noise or thermal noise has a characteristic that it has got constant power spectral density, which is can be given as eta by 2. This is the power spectral density of white noise. Power spectral density of white noise is constant, is a constant whose value is equal to eta by 2. So from the options you can select option 3 as the answer. See, this question may be asked like this: what could be the autocorrelation function of white noise? So that can be also asked. Autocorrelation means, just now we have seen in the previous question, power spectral density inverse Fourier transform is autocorrelation function. So constant inverse Fourier transform is what? An impulse signal. So eta by 2. This is Rx of tau, this one, alright. So autocorrelation function of white noise is nothing but, I can write like this, eta by 2 into del of tau. So if you remember this one also, yes, it will be very beneficial. Let us look at the next question. Yeah, if S has 3 symbols with probabilities 1 by 4, 1 by 2 and 1 by 4, then the binary entropy of S is, very easy question. See, entropy which gives the average amount of information, basically entropy gives average amount of information, denoted by H, is given by, we have one formula, summation over the I, Pi log base to 1 by Pi, log base to 1 by Pi, right. Suppose if you have different probabilities, so P1 log base to 1 by P1 plus P2 log base to 1 by P2 plus P3 log base to 1 by P3 plus so on, like this, right. And he has given the probabilities, right. So what is P1 here? In our case P1 is 1 by 4, which is equal to P3 also, and P2 is 1 by 2, fine, or this is 1 by 4 log 1 by P1 means log 4 to the base 2 plus 1 by 2 log 2 to the base 2 plus 1 by 4 log 4 to the base 2. So this is equal to 1 by 4 log 4 to the base 2 means, how can I write, this is 1 by 2, this is 1 by 2, and the third one is also 1 by 2, nothing but 3 by 2. So what is the entropy? Entropy is 3 by 2. Yes, option 3 becomes the answer. Option 3 is the answer, right. Let us look at the next question. Yeah, this is from analog communication, 51st question. The modulation index of an amplitude modulated wave is changed from 0 to 1. The transmitted power is. So first observation is, if you are going to change the modulation index from 0 to 1, definitely the power will increase. The power will increase by how much percentage it will increase means we have to calculate, right. So observe here, if I take the power, total power for a single tone AM signal, so PT is equal to PC into 1 plus mu square by 2, where mu is the modulation index. What happens if mu is 0? Mu is 0 means I will get total power in the initial case, which is nothing but PC. If I take mu is equal to 1, I will get the total power in the final case. So which is nothing but mu is equal to 1 means 1 plus 1 by 2, 3 by 2. So if I want the percentage change, it is nothing but PT final minus PT initial by PT initial into 100, right. So PT final, it is 3 by 2 PC minus PT initial PC by PT initial PC into 100, okay, or this is 50%. So yes, option 3 becomes the answer. And I think it is better to remember also, if the modulation index is changed from 0 to 1, power increases by 50%, and added to that you remember this one also. If I increase from 0 to 0.707, power will increase by 25%. Suppose if I increase from 0.5 to 1, power increases by 33%. Please remember, 0 to 1 anyway we have seen, 0 to 1 50%, right. Let us look at the next question. Yeah. In the spectrum of frequency modulated wave, he has given 4 options. The total number of sidebands depends on the modulation index. Okay, the carrier frequency disappears when the modulation index is large. The amplitude of any sideband depends on the modulation index. Okay, the carrier frequency cannot disappear with the modulation index, right. So observe here, this question can be solved like this. Here frequency modulated wave means generally we will consider wideband frequency modulation. Do you remember what is the expression for wideband frequency modulation? So it can be given as S of t is equal to AC into summation n varying from minus infinite to plus infinite Jn of beta into cos 2 pi into Fc plus Nfm into t, where Jn of beta is the Bessel coefficient, right. Now if I give different values of n ranging from 0 to infinite, what happens if I substitute n is equal to 0? AC into J0 of beta into cos 2 pi Fct, plus if I substitute n is equal to 1, AC into J1 of beta cos 2 pi into Fc plus Fm into t, n is equal to minus 1 if I substitute, AC into J minus 1 of beta into cos 2 pi into Fc minus Fm into t, n is equal to 2 if I substitute, AC into J2 of beta cos 2 pi into Fc plus 2Fm into t, n is equal to minus 2 if I substitute, Fc minus 2Fm into t, plus so on. Now if you observe here, this is carrier component, this is upper sideband, or I can say upper sideband 1, this is lower sideband 1, this is upper sideband 2, and this is lower sideband 2, and so on. Here if you observe the third option, that is this one, the amplitude of any sideband, either upper sideband or lower sideband, is depending on the modulation index. Modulation index means it is depending on the value of Bessel coefficient, which internally depends on the modulation index beta. Here beta is known as the modulation index. So option 3 can be taken as the answer. This is the next question, and in this question he said which one is correct with respect to a simple AGC. AGC stands for automatic gain control in a radio receiver. First of all, what is the purpose of AGC? See, AGC is used to adjust the receiver gain receiver gain so that output of the receiver remains constant irrespective of the nature of input. So this is the purpose of AGC, that is automatic gain control. So among the options, an increase in signal strength produces more AGC. Yes, you can select option 1 as the answer. Option 2, no, the highest AGC voltage is produced. The faster the AGC time constant, the more accurate the output. The audio stage gain is normally controlled by the AGC. Option 4 is also correct answer. Here it seems that option 1 and 4 both are correct. Okay, this is the next question. In this question he said a super heterodyne receiver with an IF of 450 kHz is tuned to a signal at 1200 kHz. The image frequency is, okay. So here IF, intermittent frequency, he gave, which is nothing but 450 kHz, and here is tuned to a signal at 1200 kHz, means Fs value he gave 1200 kHz. Image frequency denoted by Fsi is nothing but Fs plus 2If. So it is 1200 kHz plus 2 times of 450 kHz. This is 1200 kHz plus 900 kHz, which comes to be 2100 kHz. Option 3 becomes the answer. Hope you understood this one. Next question. Yes, 55th question. Good voice reproduction via PCM requires 128 quantization levels. Its bandwidth of voice signal is 4 kilohertz, then the data rate is, okay. So this is a problem related to PCM. Quantization levels 128 he said, means what? L is given by 2 power n, 2 power n is 128 means 2 power 7, implies n is equal to 7 bits per sample, right. So its bandwidth of voice signal, bandwidth he gave, means the highest frequency component in the voice signal is 4 kilohertz. Data rate he is asking, means RB value, bit rate or data rate. So what is the expression for bit rate? RB is equal to NFS, bits per second units. N already we have, Fs. So Fs is 2 FM, sampling frequency. So he didn't specify at what rate sampling is done. So we will take it the Nyquist rate. Fs is equal to 2 FM. 2 FM is 8000 samples per second. So RB is equal to 7 bits per sample multiplied with 8000 samples per second. So here sample gets cancelled. This is 56,000 bits per second. This is 56 kbps. 56 kbps, and option 3 becomes the answer. What is the answer? Option 3. Right? Next question. In which of the following modulation technique 2 or more bits are made for transmitting at once on a single signal? Yes. Suppose here he has given the 4 options. If you observe the first option, second option or third option, these are called, see, ASK means generally, if not, it is binary amplitude shift keying, binary frequency shift keying, binary phase shift keying. These are binary schemes in which either 0 or 1 is transmitted into free space using a high frequency carrier. And if you want to transmit more than one bit, you have to go for these kind of schemes, M array schemes, in which more bits, so M bits are transmitted. Here M array means M bits are transmitted into free space, right? So here 2 or more bits he is asking now, so you have to select option 4. Fine. Next question. Yes. Consider a linear delta, DM means delta modulation system designed to accommodate analog message signals limited to bandwidth of 3.5 kHz. Okay. A sinusoidal test signal of amplitude A max is equal to 1 volts and frequency FM is equal to 800 Hz is applied to the system. Fine. The sampling rate of the system is 64 kHz. Minimum value of the step size to avoid overload is, he gave the 4 options. See, sinusoidal test signal, whenever we discuss delta modulation, for sinusoidal message signal, we will see the step size for avoiding slope overload distortion. And you have to remember also, that is given by, basically it is delta by Ts must be greater than or equal to 2 pi Fm into Am, or delta greater than or equal to 2 pi Fm into Am multiplied with Ts or divided by Fs. Now here what will happen? Delta greater than or equal to 2 pi. So Fm is how much? So Fm is 800, he gave now 800, fine. So 800 into Am 1 volt by Fs is 64 kilohertz. 64 kilohertz means 64 into 10 power 3. So if you simplify from the options, you will get 78.5 millivolts. Delta must be greater than, delta means step size must be greater than or equal to 78.5 millivolts, or minimum value of delta is 78.5 millivolts. Option 4 becomes the answer. Right? This is the next question, and in this question he said the bandwidth required for transmitting binary FSK signal is, and he gave the 4 options: 4FB, 2FB, FB by 2. Basically the bandwidth required for transmitting FSK or ASK or PSK will be given in terms of bit rate RB, which is nothing but 1 by TB. Here FB is also taken to be 1 by TB, 1 by bit duration. So FB or RB both are same, and among ASK, FSK and among ASK, FSK and PSK, FSK requires more bandwidth. So here the more bandwidth case is option 1, 4FB. So you can select option 1 as the answer.